Hello everyone, in this episode we're going to continue off with our commands, and we're going to go ahead and do something a little different. We're going to make some small changes to our command system and how the coroutines run, so that way we can actually skip coroutines and proceed on to the next line of dialogue even when we have coroutines running, and even if we're set to wait for an amount of time and set to wait for a command to end. That way we can force it. Just like if a character, or good lord, a character, just like if a viewer or a player is playing your visual novel and they decide to just click through, we want to be able to stop certain actions and force complete them, depending on if the user clicks before it's actually completed. So that's what we're going to be working on today. In this test file here, we have a wait, and we're giving our characters into the scene, and then we're going to wait for Stella to move to the opposite side of the screen, at which point then Stella's going to speak, and then our guard is going to move to the other side of the screen, and then our guard is going to speak and say something, and we want to be able to skip through these tasks. So at the very end, we'll also say, Raylene says, I don't know. Okay, so we want to be able to skip through these actions and have them force complete as we proceed to the next lines. Now, some commands you might want to force complete, or maybe you don't want to do that at all. But there may be some instances, especially during wait periods, where you don't want to force the player to have to wait through something that they can skip through, such as waiting for this character to move to a position that may be necessary for your novel, but sometimes it's really not. So let's go ahead and get started on that and make that possible. So our command manager is running right now, where it only has one process running at a time. And we can check if that process is running and kind of yield until that is finished. And that works great when we want to yield until this one certain process is completed. Once it's done, then the active process on the command manager is done, and it's empty, and we move on to the next thing. But in the event of this line, we have several processes that are going to run at once. So let's change that first of all to a list of active processes that we can keep track of, and then kill those processes whenever we decide to. This will allow us to have all of these running at once, and then force complete them and stop every single one of them with a single command. To do this, let's make a new class for our command system. Create C# command process. And secondly, we are going to want to create another class to encapsulate our coroutines. The reason for this is if we look at our conversation manager where we're running commands, if we have a command that is set to wait for its completion, we're just going to straight away yield until it's done, which means we're not taking into account any key presses that could occur to trigger this command to stop and force itself to complete. So in order for us to do that, what we can do is encapsulate this into brackets and then say that coroutine C would equal our command manager instance start the arguments. And then we return C, but we are still stuck with the fact that we need to look for user input. We can't actually wait for this coroutine to end, not that I know of, without yielding returning C, which is just the coroutine, which means we are just stopping here, not doing anything else, not monitoring anything else, and we can't monitor our key presses. So we want to wrap this inside of some sort of wrapper where we can create our own function to monitor for the completion of this coroutine. So we're going to make a special class to handle that. We'll just leave this as is right now. We'll come back to it. So I'm going to come outside of core in our scripts folder, and I'm going to make a new folder and call this extensions. And inside of extensions, I'm going to create another script here and call this a coroutine wrapper. This is kind of going to replace our coroutine, and it's just going to give us an extra function that we can monitor the progress of it without having to yield by the direct duration of that coroutine. I can't find the right words to say for that, but it'll make sense when we actually start working on it. This is just going to give us a boolean that we can check and see when the coroutine is done. Okay, so let's go ahead and remove all of this first of all, and let's go back to our command process. So this command process, the reason this is important is we're going to cache all the different processes that are running at one time in our visual novel, so we can keep track of all the commands running in the background and stop what we need to. So we need to keep track of the command that's running, the coroutine, and we'll have also an action that can be executed if this command happens to be terminated, such as if we terminate this, or the user clicks and forces this process to terminate while the character is moving, the end action will force the character to immediately set their position to the original target. So everything will force itself to complete, and we shouldn't have any errors further down the line as characters click and click and click and click. So we'll want a way to identify each command individually, and the best way that I can think to do that is with a GUID, which is a unique identifier that could be assigned to every single object. Now, we can't use the Unity editor GUID because the editor is not going to be available when we export the game. So we have to use the system GUID instead. So we'll come and say using the system namespace. So we'll make ourselves a public GUID, and this will be the ID of the process. So we can either kill the process directly, or we can kill the process by its ID if we happen to cache that somewhere. And let's make also ourselves a string for the process name. This is the name of the action that's executing. So that would be move, or create character, or set visibility, what have you. And maybe we'll make this a container for all the data of the command, so that way we're just passing one variable through the command manager instead of multiple variables. So inside of here, we'll actually store the system delegate that is the actual command that we're running. This, of course, will take the place of the manual pass-in of the string command name and the delegate. We'll just be passing in an actual process data type here. So we have our command, and then we'll also have the arguments that go with it. So a public string for the arguments, right there. And then the action that can execute if the user terminates this command for any reason during the middle of it. Something that's going to execute to force it to complete or do something in that event. So we'll make public, this is going to be a Unity event, and we'll call this on terminate action. In order for us to use the Unity event, we also need to use the namespace Unity engine.events. So we get the ending action, and then we're going to want a reference to the coroutine that's actually running, which is running this delegate command. So that's going to be the coroutine wrapper that we made. That way we can keep track of it while also monitoring for key presses. So let's make public coroutine wrapper, and this will be our running process. So to create one of these, let's go ahead and make ourselves a constructor to make it easier on ourselves. Command process. And we're going to take all these values n. Now I am going to default the terminate action to null. That way we don't have to provide that in, but we do need to provide all of these other things. So this is the new data type we're going to use for our command manager. So let's hop back into our command manager and give ourselves a list of active running processes. We're just going to go ahead and make this a private list of command process, and this will be our active processes. And let's go ahead and remove the process here, because this is, we're no longer going to have just one running, but we're going to have potentially many. And we're going to make a private command process, which will be our, call this the top process. It'll be the top one at the list. and we'll point that to active processes first or default, using the link namespace to get the first process or just return null if we have no active processes. Now, when we execute, we are returning just a regular coroutine. So we're going to return that coroutine wrapper that we made earlier, just so we can track some additional things as we're monitoring for the completion of the coroutine. So we're going to go ahead and do the same thing we're doing here, but we're also going to change start process to a coroutine wrapper as well. And here's where we're going to change up slightly. So first of all, since we're not just doing one process at a time, I am changing that. I'm going to remove our stop active process so we can have multiples of them running, and we're just going to create a new process. So we're going to say system.guid, and we'll make this a new process ID to assign to our new process equals a new GUID. And now let's go ahead and create the process by making a new command process data type called cmd equals new command process. And what we need to pass in is our process ID, and we need to pass in the name of the process, which will just be our command name, and then the command we're going to run, which is the delegate, and then some kind of running process, which we're going to set to null for now because we don't have it yet. And our arguments, we're going to set that to args, and our terminate action will also be null because we're going to assign that from the actual command that runs. So it's going to assign its own termination, which allows us to define the logic for when each individual command is terminated prematurely. They can all behave differently according to what we need them to do. So after we create the process, we'll say active processes.add cmd that we have just created. And now let's go ahead and create the coroutine that will run this process that we're making. So coroutine, we'll just call it co equals start coroutine running. Okay. And now we can go ahead and assign the process. So we'll come in and say cmd.running process equals something. We need to make a new coroutine wrapper, but we need to give it some information. We need to tell it what it's doing. So let's make a constructor here. So public coroutine wrapper. And we want to pass in something that's going to run the coroutine, so we'll have the owner of it. And only a mono behavior can do that in Unity, so we'll specify a mono behavior as the owner, and we'll also specify the coroutine as the, we'll call it a coroutine. And then we'll just make private mono behavior owner and private coroutine. So then this dot owner equals the owner that's going to be running the coroutine, and this dot coroutine equals the actual coroutine. So when we create this new wrapper, we'll go ahead and say this, the command manager is going to be running it, and the coroutine that we're assigning is co, the started process. And to satisfy our return type, we're going to go ahead and return cmd.running process. So we return that wrapper. Now, as for these commands, the stop current process and running process, when they're running, they're assigning process to be null, which doesn't actually work because process is now a retrieval variable. So we just need to make a quick way to kill any running processes that we have. So we'll do a private void called kill process. So you know what, we'll make that public. This is a class I will reuse, and we may use this elsewhere to actually kill specific processes. But we'll go ahead and pass in a command process for what we want to kill. And instead of saying process equals null, we'll go ahead and now call that function and pass in a particular process. So when we want to kill the active running process, we need to first track it, which means we don't want to pass in our delegate and our arguments. We want to pass in the the actual process here. So I'll just remove that real quick. And I'm going to change the input to a command process type. Then waiting for process to complete, we'll go process.command and process.arguments. And when we start this, all we'll pass in is our command process. So when we want to end it and kill it, we'll just kill process process. As for stopping the current process, we'll go ahead and check something real quick. We'll say if our top process is not equal to null, then we're going to kill the process of our top process. We're just going to kill it. The only thing we're going to do in this function is, right now, we're just going to remove it from our active processes. That's enough for the moment. We'll come back to that later. For now, let's continue what we were working on. For now, we've got all this looking good, so let's jump to our conversation manager and go ahead and take care of that key press watch we're looking for. So if the command that we're currently running is set to wait, as of right now, we are forced to wait until that's done. No questions asked. So instead, we're going to go ahead and change this up to where we can interrupt that and stop it. So let's instead change from coroutine to coroutine wrapper and call this CW. And we'll make this equal to command manager dot instance dot execute followed by our command name. I could just cut this and paste that right there. There we go. We are done. So we have the wrapper, and now we can check something. Let's jump into our wrapper real quick, and let's make ourselves something to check. A public boolean called isDone. This will tell us whether the coroutine that it's checking is done or not. And by yielding until that boolean is false rather than yielding for the coroutine itself, that now allows us to execute some actions while we are waiting. So we can say while not cw.isDone, and we can do something inside. Yield, return, null for the moment. And let's check if user prompt. This is triggered whenever we click the screen or whatever key press. If we look at that, all this is done is it's set to true once this command on user prompt next is called active. For now, we just have this being triggered to true whenever we click the button on the screen or we hit the space on our keyboard. So if user prompt, then we're going to go ahead and say command manager dot instance, and we want to stop the current process. That's not currently a method publicly accessible, so let's jump back to our command manager, and let's go ahead and make this public. So command manager instance, stop current process. It's going to go ahead and stop it, and then we'll reset user prompt to false. And that means let's come back to our kill process function and make it actually stop the coroutine that's running. So let's check and make sure that we do have one that's still running. So let's see if cmd.running process is not equal to null and not cmd.running process.isDone. If it's not done, then let's stop it. We'll say cmd.running process, and we don't have a stop function just yet, but let's go ahead and go back into our coroutine wrapper and create one. Public void stop. Simply all we're going to do is we're going to reference the owner and say stop coroutine followed by whatever coroutine is running, and then we'll go ahead and say isDone is true. And this allows us to go ahead and stop the coroutine whenever we kill the process. After that is done, if we have an action that is set to execute once we terminate this, let's go ahead and invoke that. So we'll say cmd.onTerminateAction. We'll add a question mark and say .invoke which means if it's null, we're not going to try to invoke it, but if we do have an action, then we're going to invoke whatever logic is set to run. So this means we should be able to go ahead and interrupt this wait command. So we are waiting. Let's go ahead and wait 5 seconds. That way it's something long and we can go ahead and skip it. I do have a slight oversight here. I need to remove mono behavior from my command process class, as well as from the coroutine wrapper. Neither of these should be mono behaviors at all. So if we launch this, we should see that we are waiting 1, 2, 3, 4, 5. So after 5 seconds, we get those characters show up. Let's go ahead and skip that. It should be monitoring for our key press, and when we press, it should go ahead and quit that command, which I click and it immediately stops it. Let's go ahead and do that again, and I'm going to immediately click so we can really see this work. Yeah, all right, so we are effectively able to skip that waiting. And since it's only waiting, it doesn't need any kind of termination action. It just needs that coroutine to stop. So that's working. But now let's go a step further and let's add some logic to work, say, if we terminate the movement of the characters. Like I said, we can terminate wait and not have to have an action execute because all we need to do is just stop waiting. But for moving our character, like right here, we need to make sure that if we skip this, our character gets assigned to that position at the very end. Now, so we're going to do this directly within our database extension for whatever commands need to execute some termination logic, some premature termination logic, that is. Now, whenever we execute a command, immediately when this command starts running, it's automatically going to run with a new process created in the command manager. And that process will be immediately accessible as the top process because it's going to be the most newly added one to this list. So without any reference to the process itself, through the database and through that process variable, the top process variable, we can actually grab the newly created one for this specific function. So if we come down to move character right before we get to immediate, actually right before we start yielding, we could go ahead and right inside of here, we could add an action to our process to force the character to set its position to the target if it gets terminated. We just need a way to add that to our process. So let's go ahead and do that directly from within our command manager. Let's go ahead and make a public void and call this add termination action to current process. And instead of a Unity event, what we're going to use is a Unity action, which can be assigned to our event. And here, what we're going to do is let's first check if top process equals null. If it does, return and do nothing. But if it doesn't, then let's go ahead and see top process dot on terminate action equals a new Unity event. Once we have this new event created, now we can assign the logic to it. So we'll get top process, just so we don't have to keep calling that over and over again. I'm going to cache it. Command process and call this process equals top process. And then just replace these. So then process.on terminate action dot add listener, and we'll add whatever action it is that we're passing in. So if we go back to our move character right here, what we can do is quite simply just say command manager dot instance dot add termination action to current process, and then let's add some sort of function here. We'll use lambda to make this real easy on ourselves, and just make sure that if we terminate this prematurely, all we're going to do is say character dot set position to whatever position we were trying to apply to the character. And if something crazy happened and this character no longer exists, to prevent an error, let's precede that command call with a question mark. So that way it won't do anything if the character's null for some reason. So if we end this prematurely, following the logic that we've set up so far, it should immediately set the position of our character. To really test this out, I'm going to make Stella move to her position at a very slow speed. So her speed is going to be 0.1. So we start. We're waiting those 5 seconds. I'm going to skip that. And Stella's moving to the bottom. I'm going to go ahead and click now. And we can see we skip, and she immediately gets set to her target position. So we can see that is working quite nicely. And for anything gradual over time, any commands that we'll want to make sure get finished, even if they're skipped, then we're going to want to make sure that we just add this line and add whatever kind of logic needs to come after the command. So let's quickly do this for the other commands that we have to run. So show all is one. So inside of our show all IEnumerator, right before we go to yield until all of them are visible, let's go ahead and add that command. So command manager dot instance dot add termination action to the newly created process. And we're going to go ahead and do lambda and then just set this on a new line because we're going to need to check something. We're going to want to go through for each of these characters and make sure that they're all visible. So for each character, character in characters, let's go ahead and say that character.isVisible equals true. So we'll immediately set them to be visible. And let's copy that, open up hide all, down the bottom here, paste that in there, but set isVisible to false. Now, to make this easier to see, I've come in and I've made an additional parameter for hide and show, which is speed. I do this by setting another variable for speed and then trying to find a parameter based off of those labels and getting that speed and sending that to show and hide. That would not currently be available in your show and hide. So what I did is I added it as a simple multiplier, passed it into showing and hiding along with whether it will be visible or not, which just takes in that additional speed multiplier. And when we look at the other characters, the other character types, the only thing I've done with that value is I've taken it and multiplied it by the speed at which the alpha transitions to its target. So by causing the characters to show up and hide with a speed of 0.1 as a multiplier, they should fade very slowly, and we should be able to see the change when I click and interrupt the process. We get our characters, and Stella, as soon as I click, they're going to start fading out. Now they're fading, I click, and they fade in. So they didn't set their actual target. They didn't actually run that logic and initiate their termination. And the reason for that is pretty straightforward. If we come to a conversation manager, the only time we're actually running the stop current process is if we have a command that has set to wait. So only if we're waiting for that command to complete, we're going to stop it and terminate it. Whereas that is only move character. Hide is not waiting, and show is not waiting. So what I'll need to do instead is after I choose to click to go beyond this dialog, because if I'm not telling this line to wait, it's just going to go ahead and run this and immediately proceed to the next line and start showing dialog. So as this command is starting, we're now getting this dialog. So naturally, it's, to me, this line and this line are one and the same, basically, because they both execute at the same time. So if we consider both of these to be the same line, then once we exit this and proceed on to the next line, that is when this logic should terminate and should set itself where it should be. So if we're going to do that, we'll come straight up to the logic where we run all of these different commands. And so we'll run the dialog, we'll set the speaker on screen, and then we'll run all the commands. And then, if we have dialog, we're waiting for user input. This is where we're going to change this up a little bit. We're going to take the user input and move it here. And right after we choose to accept that user input, we'll go ahead and stop any current running processes with command manager dot instance dot stop all processes. But that's not a function for us yet. So let's hop back in here. Actually, it is a function, isn't it? Or do I only have a stop current process? I think I've only got stop current process. Yeah. Okay, so let's go ahead and make a function to stop all of the current running processes. Public void stop all processes. What we're going to do here is we're going to loop through all of our active commands. So for var c in active, let me try to type right, in active, what was it? What did I say? In processes, yeah, active processes. Oh, it needs to be for each. So for each active process, we'll check if c dot is running. If c dot running process is not equal to null and not c dot running process dot is done, then we'll say c dot running process dot stop, and then c dot on terminate action dot invoke only if we have an action to invoke. And then once we're done with all that, we'll go ahead and say active processes dot clear and clear out that list. Okay, so in our conversation manager, now we can say stop all processes. So when I decide to go beyond this line, while this logic is still running, it should go ahead and force this to complete and start executing the next bit of logic. So we run it, they fade out, I interrupt, and I can interrupt all of it and force them to complete. But there's one step that I really need to change here because this is not correct at all, and that is our top process. It should not be first or default, it should be last. If it's first or default, then it's always going to get the process that was assigned first, obviously. But if it's last, then it's always going to get the final process that was created, which would be the last one made right before the command that's being called. So if we don't do last, then we're never going to assign those termination actions correctly. And now where I was having some issues that you couldn't really see on screen, now I can click through all of these and skip all of these as I desire to, including that movement there with those two actions running together, which is what I was having a problem with just a second ago. If you want the players for your visual novel to be able to skip these functions whenever they're going to mouse click, then you want to make sure that for every IEnumerator, which means every function running over time, that you want to make it able to be terminated by giving it a termination action assigned to the last created process. So whatever function it is you're working on, if it's an IEnumerator and you want the character to be able to skip it, make sure you assign it a termination process, which does basically whatever you need it to here. And that is all I'm going to do for this video. We're going to end it off here. And for the final episode with these dialogue files, we're going to, at least for the characters that is, we're going to go ahead and move into the local character commands where we can call commands directly after a character name. So I'll see you in that one, and goodbye.